Here we have two problems that, based on the title, you can probably tell are going to require rational equations to solve. Before just watching me go through the solutions to these problems, I really want you to give both of them a try yourself. See if you can figure it out. They require a little bit of thinking, but you'll get a lot more out of it if you've actually tried it yourself first. So pause the video here, try them both, and then you can unpause when you get super stuck. At first glance, you might think this problem actually isn't too difficult, but it actually is a little bit more complicated than you might think. I've just drawn two taps here filling into a bucket, not that exciting. So if both taps are pouring at the same time, we can fill the bucket, basically, and that takes 3 1/13 minutes. And that's 3 1/13 minutes to fill a bucket. So we can say that as per bucket, right? I'm going to actually turn that into an improper fraction. It's a little bit nicer to deal with. 13 times 3 plus 1, 40 over 13 minutes per bucket. Right? When both taps are on. So the question is, if the individual taps are running, how long would it take each of them to fill the bucket? Should it take longer or shorter amount of time than the 40 over 13 or just over 3? The answer is each one individually should obviously take longer to fill because only one tap is on at a time. So maybe a good way to start would be to define a variable. What do we want our variable to be in this case? Maybe let's make our variable, let's just call it x, and let's make x, I'm actually just going to put this up here, let's make x is the time for tap 1, we'll just call this tap 1 and this tap 2 arbitrarily, time for tap 1 to fill bucket. In the question, it says it takes the other tap 3 minutes longer to fill the bucket, right? So we can say x plus 3 is the time for tap 2 to fill the bucket. Okay, that's a good starting point. Now the question is, how do we combine these two equations here with this 40 over 13? You might be tempted to just add it together, right? Like x is the time it takes one bucket plus x plus 3 is the time it takes the other bucket should equal our total time, 4 over 13, or 40 over 13. But does this actually make sense? Remember, if both taps are pouring at the same time, shouldn't it take less time to fill than if they're pouring individually? So this doesn't make any sense because this would mean that tap 1 by itself has got to be less than this and tap 2 by itself has got to be less than this because they add up to that. So this actually does not make sense. This is not the right way to go about it. I think the easiest way to think about this question is like this. We are given units of minutes per bucket, right? So x here would be how many minutes to fill one bucket. X is in minutes per bucket. X plus 3 is in minutes per bucket. And the 40 over 13 is in minutes per bucket. What if we flipped that around and we tried dealing with buckets per minute? Bear with me for a second. If we had one tap, this is just an example off to the side. I'll do it in green so we don't get confused. If we had, for example, a tap that can fill 3 buckets per minute, and we had another tap that could fill 2 buckets per minute, how many buckets could those two taps together fill every minute? And that answer we could just add up, right? That would be 5 buckets per minute. So buckets per minute is much more useful than minutes per bucket, right? Because 3 buckets, 2 buckets, combine those, we would get 5 buckets. So back to our example, how can we turn minutes per bucket into buckets per minute? Well, if we just flip this, it's going to end up being buckets per minute. So to flip this, we got to flip this, right? So essentially what that's saying is that the total time it takes, or to think about another way, our taps can fill combined 13 over 40 buckets per minute. So going over here, our taps together can fill 13 over 40 buckets per minute. It's just the reciprocal, right? About a third of a bucket per minute. This is combined, right? And what that's going to equal is the sum of the other two times, right? So X was in the minutes per bucket for our first tap. So instead, 1 over X, the reciprocal, is going to be how many buckets per minute the first tap can fill. And we can add to that the 1 over X plus 3 buckets per minute of our second tap, right? So to go back, so this is for tap 1 and this is for tap 2, right? So if you think about that example that I did before, right? This is going to be some number. So like with the example that I actually had before, the green example I did over there, this would be our 5 buckets per minute. This would be our 3 buckets per minute and our 2 buckets per minute, right? If we just add those numbers up, we get the 5. So this actually makes a lot more sense than dealing with minutes per bucket. So what we've essentially set up is an equation that's a rational equation that we should be able to solve. So we can ignore the units for now. We know that X is going to be in minutes. So at the end, our units are going to be in minutes. But I can just condense this whole thing to look something like this. There we go. Now we have an equation for the total time it takes to fill, or actually the total number of buckets we can fill per minute. This is an equation we could solve. So you know how to do that. Pause the video now, see if you can solve this equation. Unpause when you're ready to see the answer. So after expanding and simplifying, setting the equation equal to 0, we get 13x squared minus 41x minus 120. This is one that I don't think we'll be able to factor. You can maybe try, but I don't think so. So instead, let's just use the quadratic formula. I'm going to skip that step, but I'm just going to tell you, using the quadratic formula, you get your answers as x equals 5 and approximately negative 1.85. I rounded in this case. I don't need an exact answer because it is a word problem that we want a decimal answer to at the end. So is it possible that x equals, remember, what does x stand for, first of all? Well, if we go back to our question, we said x is the time for tap 1 to fill the bucket, right? So does it make sense that x equals 5? That does make sense, right? It'd take 5 minutes to fill the bucket. Does it make sense for x to equal negative 1.85? Not really, right? It doesn't take negative time to fill the bucket, so we would call that extraneous, right? We don't need to worry about the negative 1.85. So if the answer x is 5 is how long it takes to fill the bucket, with tap 1, how long should it take to fill with tap 2? Well, that's just x plus 3 should be 8 minutes for tap 2. Let's go back to our original problem and see if this makes sense, right? So it's saying it takes 5 minutes to fill bucket 1 and, fill the bucket with tap 1 and 8 minutes to fill the bucket with tap 2. Does that make sense in terms of this? It just takes over 3 minutes to fill the bucket with both taps together. And remember what we said, it does make sense. It makes sense that it takes longer for them to fill the buckets individually. We can also check our answers by plugging it back into our equation, right? So if we look at what this equation is up here, remember this is our equation in terms of buckets per minute. So if we plug it back into that equation, we can very quickly check if we're right. 13, so let me call this the check actually. 13 over 40 is going to equal 1 over 5 plus 1 over 8, right? And does this end up working out? If you do the math, you actually can multiply, you can find your common denominator, or you can just use your calculator to do it, but it does end up being 13 over 40. So this does work out. One more thing. in terms of our minutes per bucket, so this was our buckets per minute, right? So basically what this is saying, just to go back, just in case you're still a little bit confused by how we got this equation, think about it like this. In terms of buckets per minute, tap 1 can fill 1/5 of a bucket per minute, right? And tap 2 can fill 1/8 of a bucket per minute. So combined, they can fill 13/40 of a bucket per minute, or about 1/3 of a bucket per minute. And that makes sense because it takes just over 3 minutes when both taps are running, right? So hopefully that makes some sense to you. The last thing we should do is have some sort of final concluding statement so the teacher doesn't have to go look for your final answer. So therefore, tap 1 takes 5 minutes to fill bucket, and tap 2 takes 8 minutes. There we go. So problem 2, hopefully you've given it a shot yourself. If not, pause, try it yourself. With now how you know we solved the first problem, it's sort of a similar process for this one. So the first step in a problem like this is to probably define some variables, right? We want to know how many shirts were in the case, so a good variable might be X, and we can call that the number of shirts in the case. Okay, now that we've got that, the next thing to remember is the terms like profit, cost, and revenue, right? And profit, so how much you actually make, is always equal to the revenue minus your costs. So that means revenue is how much you make from selling them minus the cost it was for you to buy the shirts in the first place. Whatever's left over is going to be your profit. So we basically need to figure out what these three things are in this question. Now we're given a profit of $10 per shirt, right? So maybe a good approach is to look at this in terms of profit, revenue, and cost per shirt, right? So per shirt, revenue per shirt, and cost per shirt, right? So we already know the profit per shirt because that's given to us in the question. So we know that this is 10, right? $10 per shirt. So the next thing is the revenue per shirt. Well, we know she makes a total revenue of $560, right? So in order to find the revenue per shirt, we just need to divide the revenue, 560, by how many shirts she sold, right? How many shirts did she sell? Well, X is the number of shirts in the case, but remember, she kept 2 shirts for herself. So wouldn't X minus 2 be the number of shirts she sold? That's true, right? So the revenue per shirt is just going to be 560 divided by however shirts were in the case minus 2, right? And then we're going to subtract from that the cost per shirt. So she bought the case for $450. And per shirt, how many were in the case? Well, that was just X. So there we go. We actually have our equation already. So just simplifying this, 10 equals 560 over X minus 2 minus 450 over X. That's our equation. So once again, I want you, pause the video here, do the solving, come up with the answer. Unpause when you are ready. So after all that algebra, what you end up getting is that the X values it comes out to are 18 and -5. Remember, X refers to the number of shirts in the case. So -5 obviously doesn't make any sense. That's extraneous. So that means essentially 18 shirts are in the case. We can obviously check this. Are in the case. Oops. Are in the case. We can obviously check this by going back up to our original equation, right? So if we plug in 18 here into x, we should get out our well, the left side should equal the right side, right? So 10 equals 560 over 18 minus 2. So it means basically she kept 2 shirts for herself and she sold 16 of them, right? 450 over 18. So just very quickly doing this math, 450 over 18 is 25. 560 over 16 is 35. So that makes sense. 35 minus 25, and that equals 10, right? So that does make sense. Essentially, she sold each shirt for $35. They cost her $25 per shirt. And the difference between those is her profit per shirt, which was $10. So it does make sense, and we're good to go.